Welcome to video lecture, a course material on OML 753 selection of material by Vinod Kumar, Assistant Professor, Department of Civil Engineering, Rogni College of Engineering and Technology. Today we are going to learn a topic, testing of metallic material. Metallic material testing standard focus on hardness, tensile and fatigue strength, approaching the issue from multiple angles to provide a range of information. Together, standard testing provide valuable information to determine the reliability of metallic material and the product of structure using them. The American Society for Testing and Material (ASTM) is one of the world's largest standard development organization, with over 34,000 members responsible for more than 10,000 standards. And second point is the tensile and compressive property testing, creep and stress relaxation testing, hardness and impact testing, fracture toughness testing, fatigue testing and other mechanical testing. These are the testing conducted in the metallic materials. Tensile and compressive property testing. These tests are typically performed using a universal mechanical testing instrument. A tensile test is a method for determining behavior of a material under axial tensile load. A compression test is a method for determining the behavior of a material under a compressive load. And the second test is creep and stress relaxation testing. A creep test, sometimes referred to as stress relaxation test, is used to determine the amount of deformation a material experiences over time while under a continuous tensile or compressive load at a constant temperature. The next one is hardness and impact testing. A hardness test is typically performed by pressing a specifically dimensioned and loaded object into the surface by a material you are testing. The hardness is determined by measuring the depth of penetration or by measuring the size of the impression left by an indenter. And the next one is fatigue testing. Fatigue testing is defined as the process of progressive localized permanent structural change occurring in a subject to condition that procedure fluctuation stress and strain at some point or point that may be cumulative in crack or complete fracture after a sufficient number of fluctuation. The following are some of the major reasons for testing. The first point is to prove design concept, and second one is to provide a base reliability, third one is safety, protection against produce a liability suit, and fifth one is quality control, and sixth one is to meet standard and specification, seventh one is to verify the manufacturing process, and eighth one is to evaluate competitor product, and ninth one is to establish a history for new material. These are the major reasons for testing a material. And the next heading is test for elevated temperature performance. Designer and material selector of plastic product constantly face the challenge of selecting a suitable plastic for elevated temperature performance. Many factors are considered when selecting a plastic for high temperature application. First one is short term effect and second one is long term effect. The short term effect covers heat deflection temperature, Wickett softening temperature and torsion pendulum, while the long term effect comes under long term heat resistant test, underrated laboratory test, and the creep modulus or creep rupture test. Brittleness temperature. Brittleness temperature is defined as the temperature at which plastic and elastomer exhibit brittle failure under impact condition. Yet another way to define brittleness temperature is the temperature at which 50% of the specimen test exhibit brittle failure under specified impact condition. These are the brittleness temperature of a material. Thank you.